In this video, we're going to talk about current dividers and voltage dividers. And what they are is just basically two different ways to set up resistors so that one would separate the current, the total current that comes in, and the other one would separate the total voltage across different resistors. So first we have resistors in series. Let's call this R1, the other one R2. This is resistors in series. So when you connect resistors like this, you have a voltage divider because the current going through both resistors would be the same. Let's call it I. And the voltage across R1 would just be VR1 equals IR1. And the voltage across R2 would just be VR2 equals IR2. And if we want to know the ratio of the two voltages, then that would just be VR1 over VR2 equals IR1 over IR2 equals R1 over R2. So as you can see, the voltage of the two, the ratio of the two voltages is just the ratio of the two resistors. And when you connect two resistors in a different way, that is in parallel, then we have a current divider. Notice that I draw two dark dots where the wires are connected. These are used to indicate that the wires are actually connected. So if I don't have the dots, let's say in this example, if I don't have the dots, then the wires would actually be not connected. They would go over each other so that there's no current interference. So we have two resistors in parallel, and since they both come from this dot, and then the current would go through both resistors and then come back to this dot, the voltage across both resistors would be the same. VR1 equals VR2. But we also know that VR1 equals let's call it I1 R1, and VR2 is I2 R2. So these would be equal. So move things around a little bit. We have I1 over I2 equals R2 over R1. So the ratio of two currents are actually the 1 over the ratio of the resistors values. So if you have a bigger resistor here, then you actually have a smaller current value here. It makes sense because the more resistance you have, the more you're going to resist the current. So the current is going to go the other way more, but that does not mean that the current doesn't go through this resistor at all. So let's do an example. First, we have two resistors in series. Let's say this is 1k ohm, the other one is 2k ohm, and we have a total current of 1 milliamp. Then the voltage across this 1k ohm resistor would just be 1 milliamp times 1 kilo ohm equals 1 volt. And similarly, the voltage across this 2 kilo ohm resistor would just be 1 milliamp times 2 kilo ohm equals 2 volts. So the total voltage would be 3 volts, but then you can see that this 3 volts is divided between two resistors, and the ratio of the two voltages across these resistors is the same ratio of their resistance values. Now we have, let's give it same 1 kilo ohm and a 2 kilo ohm resistor. And let's say now the voltage between these two dots would just be let's give it 2 volts. So we know that the 2 volts is shared by both resistors. So I1 would be 2 volts over 1 kilo ohm, and that would be 2 milliamps. And I2 would be 2 volts over 2 kilo ohm, and that would be 1 milliamp. So you see, the current gets divided between the two resistors, and the ratio of the current is actually the reverse ratio of the resistors values. And that's why we call it a current divider.